Assalamualaikum and good day everyone. The main topic of this chapter is design of structured timber beam and column. Before we go to design process, it's good to know about timber material. By understanding the material, we will be able to relate during design. Let's start now. Why we choose timber as a construction material? Timber has low density and high degree of strength and stiffness, mean it offers structural efficiency as carried load per unit weight compared to reinforced concrete. Timber either naturally durable or it can be treated to make it durable. Timber has low thermal conductivity, provide energy efficient in building. Timber construction material can be installed efficiently, save time, labor and cost without having to need to rent heavy equipment for installation. Therefore, it provides energy efficiency in construction. Timber is environmental friendly material assisting in reducing carbon emission. Mean more trees are planted, so it is good for environment. Timber can be categorized into two, which are softwood and hardwood. The shape of leaf for softwood is coniferous and have needle-like leaves, while for hardwood, it has a broad leaf. Softwood tree grows faster than the hardwood. It takes 100 years for hardwood. That's why in terms of quality, hardwood timber more stronger and durable compared to softwood. Comparison between hardwood and softwood, we can differentiate in terms of the tree. This is the hardwood tree with the broad leaf, and this is the softwood tree with a narrow leaf. In terms of the cell structure, hardwood has a pore vessel, but not for softwood. This is the classification of timber in Malaysia, where it is grouped by the density of timber. For heavy hardwood, for example, the density is over 880 kg per meter cube, and this is suitable for construction timber. Example of the species which fall into categories of heavy hardwood are balau, cenggal, and merbau. You can have a look on the rest of the timber class. Timber is a natural product, so imperfection can happen to timber. There are many types of defects such as due to the insect, fungi and etc. But what I will be showing here is the main common defect. Natural defect can be due to the abnormal growth or tissue rupture in timber. Most commonly is knot. It can reduce the strength of the timber and also reduce the value of the structural use. Other defects such as wane, it can be shown by this rounded edge of timber log, and also we have the shake. This is where it occurs around the timber growth ring. We have also the timber defect due to the seasoning. Seasoning is a process of drying where moisture level of timber is reduced so it can achieve optimum strength, elasticity and durability. We have two methods used for seasoning. First is natural air and secondly the artificial drying. Normally during the natural air drying, uneven exposure from the wind and sun can cause shrinkage in the timber. So what happened? Timber can bowing, twisting and cracking as you see in this figure. Let's look at the material properties of timber. We look at first the density. It is mainly determined by the amount of wood substance per water content. So we measure it by mass per unit volume. Greater density means good mechanical properties in terms of the strength and the stiffness. Wood with the thick cell wall and small cell cavity, this is for the heavy species, have higher density and stronger species. Higher density wood tends to shrink and swell more with the changes in moisture contents than the wood with the lower density. Now let's look at the shrinkage in timber. Shrinkage is reduction in timber dimension occur naturally or during drying process. This is happen when moisture begin to leave the cell walls. As seen in this figure, shrinkage is insignificant along the length of timber. Similarly, across the growth ring, shrinkage appear less. Greater shrinkage occurs along the growth ring. Cross-section of timber distort during drying. Sometimes shrinkage can cause splitting and cracks. Shrinkage can change load path that may be potentially dangerous or costly to repair. In general, shrinkage affects strength, stiffness, and durability of timber. Timber is anastrophic material, mean directionally dependent, which implies different properties in different directions. This is because of its fiber and orientation of microfibril in cell wall. Timber has three orthogonal directions, which is longitudinal. This is the direction to grain. Radial. Direction lies along radius of tree section. And tangential. Direction tangential to growth ring. The radial and tangential direction refer to direction perpendicular to grain. Timber strength, modulus of elasticity, and other characteristics such as shrinkage and swelling different in the three directions. The strength, stability, and resistance to distortion in the direction parallel to grain is significantly greater than in the perpendicular direction. Timber is hygroscopic material, meaning it has the ability to attract and retain water. When timber contains too much water, it becomes vulnerable to potential timber destroying elements such as fungi, microorganisms, and etc. When wood is cut, it dries from green state to a moisture content that is equilibrium with the relative humidity and temperature surrounding. We call this as a equilibrium moisture content, EMC. The state where all free water has been removed and the cell water still saturated, call it as a fiber saturated point, FSP. An average FSP for timber ranging from 25 to 35%. What happens when the moisture content below FSP change in properties of timber occurs, where strength and stiffness increase. Above FSP, the properties remain same. Design code include stress modification factor to account for the influence of the moisture. The main concern of using timber in construction is adequate fire safety. This is the cross-section of timber subjected to fire. During fire, the outer timber will be burned and black. Char layer develop due to the incomplete combustion of timber when subject to high heat and partially burning so as to blacken the surface of the timber. Char layer protect unburned timber from the high temperature so that properties inside the timber less affected. Charring rate for timber is around 0.6 mm per minute. Most building code limit the use of timber in particular number of story for timber building. Timber strength depends on the direction of the grain. We look first on the parallel to grain. The strength and stiffness parallel to grain is strongest. Tensile strength of softwood parallel to grain ranges between 70 to 140 MPa, while compressive strength between 30 to 60 MPa. For hardwood, the values are high. The defect commonly not reduce the tensile strength and other properties for timber. The modulus of elasticity is same for both in compression and tension, parallel to grain, and the modulus of elasticity ranging from 7 to 14 GPa. Now let's look at the strength of timber at perpendicular to grain. Strength and stiffness perpendicular to grain is lower than the equivalent parallel to grain properties. The tensile strength at radial and tangential direction can be as low as 5% of the value in grain direction. Therefore, it's not advisable to design timber structure in such a way tension stress perpendicular to grain. Compressive strength in the perpendicular to grain is 10 to 20% of the parallel grain value. Modulus of elasticity perpendicular to grain is approximately equal in the radial and tangential direction. Due to various types, origin, and properties of wood, it is important to group the wood so it is easy for engineer to design timber structure. Timber grading is a process by which timber is sorted into groups with ideally similar appearance or structure properties in each group. Timber is specified by its grade, so it is important to understand the term used in grading and the implied properties as well as the characteristic of each grade. For us in Malaysia, we can refer to Malaysian Standard MS544 Part 2 for strength group based on timber species. This is Table 3 taken from the Malaysian Standard, where we can grade the timber based on the strength group 1 to strength group 7. Inside the table are all the species that fall into each strength categories. Basic strength properties for each strength group can be found in Table 4 Malaysian Standard. As we discussed previously, strength of timber are different according to grain direction. So we have strength parallel to grain as well as perpendicular to grain. The properties also change according to the condition of the timber, whether wet or dry. By having this material properties table, we'll be able to design our timber structure. If we're not sure what is the strength of timber we can use for design structure element, we can refer to Malaysian Timber Industry Board website to check recommended strength group of structure application. For example, for column beams, we can use a strength group of SG1, SG2, SG3, and SG4. I hope you get some understanding on timber as material in construction before proceed to design process. Thank you.